My dear students, welcome to lecture number 25. So, this is where we have started the discussion about deep learning methods, and in next 2-3 lectures we will discuss about the different techniques of deep learning methods. So, in the last lecture I give you some introduction and we will carry forward from that with that small introduction and then move into different techniques, and there are different algorithms of deep learning and how we can actually use them in different kinds of problems of modeling in material science engineering. That is the basic purpose of this. But you know, you will have a tendency, or you will have a not a tendency, you will have a outlook that deep learning means they are very difficult as compared to machine learning. That is not true. Some of these techniques actually are based on the machine learning methods you learn, like artificial neural network, but this is beyond the usage of machine learning, where we can use different algorithms for solving difficult and sometimes problems which cannot be done with a normal machine learning methodologies. That is why deep learning actually has a strong role to play. So, let me just discuss about it. As you know, machine learning is basically a widely used technique from quite long time, and this has seen that these machine learnings can solve most of the problems, but the techniques which we are going to discuss, they have very recent origin. Maybe after 2005 or so, these techniques has been developed and they have made a very strong foundations on the machine learning or deep learning approaches. So, it is basically a broad subject. We have seen that AI is nothing but ability of machines and computers to mimic human mind decision making process, and that involves also learning capability, problem solving capability, but this is quite limited. Although we think it can do everything in this world, but still it is limited. And in AI we can make the machine to learn or understand something which is happening in the world, and from that get a clue and then solve certain problems or achieve certain goals. This is basically built on these two things called machine learning and deep learning. So, artificial intelligence is basically needed to incorporate human behavior and human intelligence in machine as well as systems. That is what is the key aspects of artificial intelligence. We want to incorporate human decision making processes, human problem solving processes in the intelligent machines, but that is not so easy, right, because human intelligence has various kinds of facets. So, in machine learning we learn from data, or machines learn from data or some experience which is nothing but a data actually, and then use a model after learning to give some output, and then your task will be to check whether this output which you are getting from this machine learning model are in accordance of whatever you are expecting. And this expectation is not based on what you think, its expectation is based on an experiment or a different calculation like using some other methods. So, therefore, machine learning is basically learns from data or experience and provide a model which can predict or make predictions. On the other hand, deep learning, they are basically based on multi-layer neural networks and processing. They are not like many machine learning techniques we learn like regression or classification problems, but they are more based on this neural network type of issues. So, that is the difference between machine learning and deep learning. We will see even much larger differences between these two techniques. So, I hope it is clear to you that machine learning basically uses data or experience to learn and develop a model, and after the model is developed it can predict, and those predictions you can check using experiments or some other calculations. On the other hand, deep learning is technique which does computation or learning using multi-layer neural network methods and processing. The moment we talk about neural network, we are talking about human brain. So, as you say that this AI is basically to mimic human decision making process or problem solving process. So, therefore, best way is to mimic human brain, and that human brain can be mimicked by using neural networks. That is why deep learning methods are relatively new, and they can provide much wider problem solving capability. Well, so that in a nutshell, what I could say is that it mimics the intricate neural networks of the human brain. That is the key things of any deep learning methods. It will mimic the intricate neural networks which are present in the human brain. So, that allows us to compute autonomously certain patterns or discover certain patterns. To give an example, so in the childhood when your parents tell you that this is bicycle, but this is a car. So, immediately looking at the picture, you learn that this shape of an object corresponds to a bicycle. On the other hand, the other shape which looks like a car, but then you do not need to be taught again. In the whole of your life, if you immediately see a bicycle, you will be able to recognize. Similarly, for the car, right? That is called autonomous discovery of patterns. It is autonomously discovered by our human brain, and this is what we want to mimic in deep learning methods, and this allows computers and machines to do that. So, it requires vast amount of data. That is the key difference between machine learning and deep learning. As compared to machine learning, deep learning requires large amount of data. You must be thinking why, because when you are a kid, your parents tell there is a bicycle, and you see one bicycle and realize that is the shape of a bicycle. Well, you have to understand, we are nowhere close to understanding the human brain. So, therefore, mimicking human brain does not mean that we mimic everything of the brain. We are trying to find out the ways and means human brain makes decision, and these ways and means are limited right now. They are not like a full scale situation which can mimic our human brain, and that is why it can be used in different kinds of domains like computer vision, in order to understand an image and then read it and develop a model. Similarly, it can be also used to understand natural languages which are present in the world, whatever natural language you speak, and do this processing, so that we can actually do autonomous text creation, autonomous line text creation and speech creation. All these things are possible. Similarly, it can be also used in health diagnostics, and recently it is also used in autonomous driving. Many of you have probably seen the Google car, which can operate without a driver. So, that is only possible when you have a learning using a deep learning technique. So, what in a nutshell I can tell you, deep learning is typically based on neural network architecture, whatever we have in our human brain, and most important neural network architecture is artificial neural network architecture. It uses interconnected nodes called neurons, and that can work together to process data and learn from the data. In fact, this is basically sequential learning process, as you will see in the next few slides. So, this is key aspects you should keep it in mind, that it really mimics intricate neural networks in the human brain, and this enables the computers or machines to autonomously discover patterns, and that is very important, right. Machine learning methods cannot autonomously discover patterns, they need some kind of a supervised role of a human, then it can do that. Although I have taught you both unsupervised learning and supervised learning, and told you how unsupervised learning can work, but nonetheless I also told you that none of these methods can work without intervention of human. But here deep learning methods can actually work, they can autonomously discover patterns, and how it can do and what all it can do we will see in the next half an hour or 1 hour time we have. So, in a large scale main focus of today is what? Main focus of today is what you have probably heard of the industry 4.0. What is it? This is nothing but a typically technology driven automation. We want to automate everything, automate your industries, automate your travel, automate your whatever you can think. That is what is the idea. How do you do that? Using smart and intelligent machines. You have probably heard smart cities, okay. So, what is the smart city? Smart city is basically city which can handle different kind of thing in a smart way, like garbage collection. Can you make a garbage collection like autonomous and also teachable? That is what it is. So, hence industry 4.0 typically designed to do that, and that is what we are all aiming to achieve. Well, we are not yet very close to achieve that, let me tell you. And to achieve industry 4.0, what you need is application of deep learning in various fields like smart healthcare, smart business, smart cities, cyber security, etc. I hope you probably heard of the name called cyber security quite a lot, because of the various kinds of money fraud on the internet, whether you is using a credit card or debit card, or you are using some kind of a net banking. Many times many people have, or many people are, including me also, we have experienced this cyber fraud. How to take care of that, how to stop this cyber fraud, so that we can do that. So, that is called cyber security. Similarly, healthcare, smart healthcare is very important in today's world. Healthcare does not mean only treatment of disease, healthcare means many things. Healthcare means understanding the prognosis of the disease and also treatment, best possible treatment. So, that can be done in a smart way, right. So, DL approaches have grown dramatically, that is why post 2006, and it has given you various kinds of things. Let me tell you that deep learning machine was introduced by Hinton et al. In 2006, and this is based on a concept of artificial neural network. That is what he tell. It became a prominent topic after that, and it has probably led to rebirth of neural network research and applications. Hence, it is referred to as new generation neural network. That is why. So, Professor Hinton, he actually discovered this deep learning method initially in 2006. So, that is hardly about 20 years old subject. So, in particular, DL provides an excellent solution for uncovering complex architecture in higher dimensional data. A lot of things I told, right. First of high dimensional data means what? Data which will have many dimensions. Why only 2 dimension, 3 dimension data? It can have many dimensions, features present, and many cases the data will have a complex architecture, means data may not be straightforward, it will have different complex architecture presence, and that is why DL can play a very important role in building these models or data driven models, whatever we need today, because it has huge learning capabilities. It can change the world as well as human everyday life throughout automation power learning experiences. And DL also capable of learning from data. There is a strong relationship of deep learning with data science, that we will see, because in the last part of my course we will talk about material informatics and material data science. So, how the DL can be integrated to that. So, we will discuss about advanced DL methods and then gradually move to material informatics or data science. Well, before we talk about how the deep learning methods are, let us see what kind of data it can handle. DL models, as usual, like ML, can learn from data, and data is basically experience, right. Hence, in-depth understanding and representative of data are very important to build any kind of data driven model. So, what kind of data are actually used? Well, there are 3 types of data type we use. One is sequential data. This kind of data is where order matters actually, order is important. It is like a set of sequence, right. Let us talk about text streams, audio fragments, video clips, or even sometimes time series data. Time series of any event happen. Let us talk about lightning of you are recording lightning, where you can record as a time lapsed images. So, that is what is called time series data. Audio fragments are very common to you. Clips, video clips are nothing but reels in Facebook or by Instagram, okay, or any other kind of social media. So, they all can be, they are part of sequential data. Similarly, text streams, many times we use text streams to do that. Okay. So, that is very common aspects of data we handle, and that is something which you need to know. So, if you see that sequential data is basically it needs to be explicit account for sequential nature of input data while building a model. whenever you sequential data you have, we need to have a exclusive accounts of the sequential data, how the data has been developed to build a model, and these are the things. Now, you also have what is called image or 2D data. It is digital image. Okay, it can be made of a matrix. Yes, all of you know that actually digital data can be made of matrix, which is nothing but a rectangular array of numbers, symbols. But color image is actually 256 different these things. So, therefore, you can actually have a matrix in for a matrix and arrange in a rows and columns and 2D array of numbers. The matrix, pixel, voxels and bit depths are the 4 essential characteristics or fundamental parameters for the 2D data. Matrix is the data actually. All of you know the matrix looks like this, correct, 2 by 2, 3 by 3, 5 by 5, n by n matrix. So, it contains data, and that data actually are basically analyzed using this kind of essential characteristics like pixels. Pixels, all of you know, pixel is another picture elements, voxel is the video elements, and bit depths, actually bit is nothing but data. They are the 4 essential characteristics of fundamental aspects of the data. So, that is the second type of data, which is called image or 2D data. Now, we can also have what is known as a tabular data. It is nothing but a data in a table. Its data consists of primarily rows and columns. That is very common in this world, because it is contains data in a column format in a data sets. Each column or field must have a name, and each column may only contain data of a definite type. In Excel file you do that. When you open a Microsoft Excel, you put data in a tabular format, like you have each row and column. Basically, each column is actually one kind of a data type, like serial number, name of a student, marks obtained by student. We normally do that, right? That is what it is. So, basically, if you see any XLS file, you will get to understand that. And the important aspect of this, that overall it is logical and systematic arrangement of the data in the form of the rows and columns that are based on data properties of the features. The moment you put the data in a columnar manner or rows manner, what do? You are putting actually features, like serial number is one feature, name of the student is another feature, roll number is another feature, marks obtained is another feature. That is what you do in Excel files, right, whenever you tabulate marks after the exams are over. Similarly, you can also have a experiment in which you have a serial number, you vary the pressure, then vary the temperature, and calculate the or measure the concentration of certain elements. That is in terms of a table. That allows you to find out the features which are already present in the system. That is the essential aspects of this. So, deep learning models can learn efficiently and in this tabular models, tabular data. That is what very important. It allows us to build data driven intelligence system much easily than any other techniques. Okay. So, these data are very common, this kind of data, sequential data, image data or tabular data, very common in widespread applications of deep learning. Other than that, different categories of deep learning techniques can basically perform differently on different types of data. That is why you must have an prior knowledge what kind of data are you using, whether you are using sequential data or image or 2D data or a tabular data. So, please keep in mind these are important when you develop a DL model. Sequential data is very commonly observed, all of us actually are doing that. Whenever we are playing some songs, what we are doing? Basically, we are having a text stream. Somebody is singing a song means it is text stream, along with some instruments, right? But instrument may not be there also. So, that is about the data, but this is so now, as you know, deep learning perform much better than ML, machine learning, whenever amount of data is very large. That is why in deep learning takes a lot of time, prediction does not take. Machine learning can be handled using small amount of data. As you clearly see, the performance is marginally better for machine learning when amount of data are less. But beyond a certain value of data, deep learning actually takes over. Deep learning outperforms the machine learning methods, most of the machine learning algorithms. That is why deep learning can be used when you have a large amount of data. And this is what happened in business houses like Amazon or Alibaba. These companies, when they sell different objects, they have a huge data of customer data, and they normally apply the deep learning methods compared to machine learning methods. In material science, we may not have huge data for everything, right. In material science, some things like steels, which have been there in our system or in our world for almost like more than 100 years. So, therefore, we have a lot of data on the steels, steel manufacturing, steel mechanical properties, steel other properties. There deep learnings can be very useful compared to new materials where you have depth of data. So, never try to use deep learning for new materials, that may not work well, because as you clearly see, the performance of deep learning is poor compared to machine learning when amount of data are less or amount of data are basically in the lower side. That is one of the critical aspects of deep learning. And as you see here in these things, deep learning model can increase its performance more and more as the data amount of data increases, and that is why it is extremely useful when dealing with large amount of data, extremely useful. And this is therefore the capacity of the process can actually increase exponentially when amount of data is very large. This is very important. Now, what is the deep learning workflow? Remember, I showed you machine learning workflow also. Can we go back and do that? Three important aspects in deep learning workflow. One is the data understanding and pre-processing. So, I already told you about data understanding, right. If you clearly go back, what kind of data you are handling, sequential data, image or 2D data or tabular data, that is called data understanding. Now, you can also data pre-processing. You have real world data, you can actually annotate the data, pre-process the data. Anyway, we have not discussed about techniques of pre-processing of data, which we will do in the subsequent lectures, but these things has to be done at the beginning, step 1. So, data understanding and pre-processing is done as step 1. Steps 2 basically nothing but a model build up and training. So, models can be supervised, unsupervised or generative, hybrid, whatever it is. And what are the tasks it has? It can do predictions, it can do detection, it can do classification, whatever we have seen. Prediction is very common in all kinds of learning. It can do detection also and classify. And there are many different kinds of DL methods. We will talk about it, like CNN, RNN, ANN, GN, AE. We will see all this meaning of these terms in the later part of this lecture. So, these learning and training are the second important step, just like in machine learning. And then after it is learned, machine is able to predict or perform, and then we have to do analysis of the performance. How do you do that? By validation. And validation is basically done by using experimental data or some data which is obtained from other computation techniques. Remember, in this lecture also, in this class course also, we will talk about other computation technique like the DFT, MD simulation, other things, where we can actually calculate some kind of parameters, and that can be used to validate predictions of these DL models. And finally, you can actually interpret and conclude by what is whether the model is good or model is useful or not. So, this is the main workflow of deep learning techniques, which you have to keep in mind. So, machine learning and deep learning, I already talked about a lot of differences, and machine learning applies statistical algorithm to learn the hidden pattern or relationship in the data sets. Compared to that, deep learning uses neural network model architecture to learn the hidden pattern or relationship in the data sets. That is the key things of one of the key things of deep learning. And deep learning, as I told you, requires large volume of data sets. Its performance is better when you are using large amount of volume of data sets compared to that machine learning can handle small amount of data sets. So, if you want to discover new materials, you should use machine learning, not deep learning, because in you discover new materials or you want to handle new materials, you may not have enough data, sufficient large amount of data, and that is why machine learning is better for low level work. On the other hand, deep learning is very good for complex kind of things like image processing, natural language processing. This is very good. Computer vision is based on deep learning methods, because since models are simple, machine learning takes less time. Deep learning takes a lot of time, because it is based on a complex architecture and it is supposed to handle large amount of data. That is why it will take a lot of time to learn, but in deep learning predictions are faster. is the model in machine learning is created by relevant features, which can be manually extracted and then do the feature engineering. But here features are automatically selected. It is not, so it is basically end to end learning process. There is no manual extraction of the features which can add on that, and that is why it is less complex, easy to interpret results. But deep learning is just like a black box, we say. You cannot, it is very difficult to interpret results of the deep learning. It will give you good predictions, but scientifically explaining these results are not at all easy. As far as computational power is concerned, machine learning can work on CPUs, it requires less computation time or power. Deep learning requires high performance computing with GPUs. Okay. So, these are the basic difference between these two, which we discussed last lecture also and doing that. And I already talked about it, difference between applications of deep learning and machine learning. I will just tell you that first important aspect we do is computer vision, and there we can actually detect objects and recognize it, like image classification, image segmentations. Image segmentation, you must know that we can segment the images in different parts and find lot of NLP or natural language processing is very important. It can automatically generate the text, like in case of Gmail or in case of your texting in phones like WhatsApp or something. When you do that, it can translate language, it can sentiment analysis, like whether that particular text is talking about sorrow or happiness, it can also do that, and it can also do speech recognitions very easily. That is something which is now routine. NLP is very routine now. Okay. Many of you will use NLP to process your literature survey, right. If you want to do a literature survey on certain kind of topics, you can actually use NLP. It will do a very nice process. You can translate language, you can get data from other languages, it can actually do the sentiment analysis also of a particular manuscript or particular paper, whether it is talking about something good or something bad. The last thing it can do is reinforcement learning. We talk about it in the next slide, and it is basically part of game playing, robotics or control systems. So, basically it does this kind of complex stuffs, as let me tell you, unlike machine learning. Computer visions, which is nothing but a image recognitions, which you require in airports or railway stations or many other things, that can be done very easily by this technique. So, different methods are there. ANN is artificial neural network, we talked about it. Convolutional neural network or CNN, recurrent neural networks, autoencoders, there are many more, so I will talk about the end of this lecture. Deep belief network or DBN, and they are all widely utilized but each of these actually has one common neural network. So, that means deep learning methods are based on the architecture of our brain. So, what are the key properties and dependency, that is also you should know. Well, DL typically depends on large amount of data. You have to understand that it typically depends on very large amount of data, and because it has to develop a data driven model. Without large amount of data, it cannot produce, it cannot find out particular pattern or recognize the particular relationships. The reason is that when data volume is small, deep learning algorithms often performs very poorly. That is why you need data. In such circumstances, however, performance of the standard machine learning algorithms will be comparable with the deep learning methods. That is the data dependence. So, you need large amount of data for this. Second is the hardware dependence. DL algorithms require large computational power. We already talked about it, and because the data are large, you need to take care of GPUs other than CPUs. Thus, to work properly, these deep learning training GPUs hardware is necessary, and therefore DL relies more on high computing machines, or like supercomputers also can be utilized for deep learning methods. Third important aspect, so these are already discussed, but third important aspect is something which we will discuss now. Feature engineering process. DL actually decrease the time and efforts required to construct feature extraction. It actually does automatically feature extractions. That is what is very important. A fundamental distinction between DL other machine learning technique is that they attempt to extract the features from the data itself. That is the important aspects compared to machine learning also. Then training and execution. Training in DL it takes a lot of more time than machine learning, and it is a black box. I already told you, nobody knows how it exactly works. It is very difficult to explain how the DL works actually, but it provides you very good predictions. That is the important aspects of DL. As we talked about it, different kinds of learning, we know we are talking about supervised learning for machine learning lots. We talk about unsupervised learning also, and supervised learning is nothing but data which is both input and output, but unsupervised learning is basically based on input data. That is how we can use for clustering kind of techniques. But you also have a recurrent learning, a reinforcement learning. Okay. What is reinforcement learning? It is a machine learning technique in which an agent learns to make decisions in an environment to maximize the reward signal. It is an agent which learns. An agent will interact with the environment by taking some actions and observing the result rewards. And deep learning can be used to learn policies also. That is how, because agent can learn policies of certain government, policies of certain other things like companies can be learned also, that can maximize the cumulative reward approach. And reinforcement learning like deep Q networks, deep deterministic policy gradient are widely used to reinforce tasks like robotics and game planning. So, therefore, it is nothing but agent based learning, and agent based learning is that you employ some agents that will learn in an environment to maximize the reward. That is what is the idea of this. Now, how it is done we will discuss later also. And now, you also need to know that deep learning utilized to provide discriminating function is supervised learning. Typically, it is designed to give discriminating power for pattern classification by describing the posterior distribution of the classes conditioned in the visible data. And we will talk about multi-layer perception model and cumulative neural network models or CNN or recurrent neural network models, which are part of this discriminative learning process. So, in this part of lecture number 25, what you learn is that what are the basic features of deep learning, what are things it can do and what are the important aspects of that, whatever data it can handle and what kind of learning it can do. The next part we will talk about different algorithms which are used for deep learning methods. So, let us stop here for the part 1, we will come back to the part 2 and the next one.